Okay, so let's talk about surface area now. And just as a reminder, surface area is the sum of the area of all of the faces or outside of your three-dimensional figure. An analogy is if you needed to wrap your three-dimensional figure in wrapping paper, what's the area of the wrapping paper you would need in order to do that? So, in general, the easiest way to find surface area, I shouldn't say the easiest, but you can always do this, just split your object into its faces if you can, find the area of each face, and sum it up. And I'll put faces kind of in quotation marks here, because if you have any curved objects like the cylinder down here, well, we don't really think of faces when we have curved objects, but the same ideas will apply. Let me kind of show you what I mean here. So, here is a cube, or at least I'm trying to draw a cube. It has a top, a bottom, and then 4 sides. So the back one I colored blue, the left one is red, the front one is yellow, and the right one is green. So by splitting it up into its faces, I'm taking off the top and the bottom. That's what I did here. There they are. And then for the rest of it, rather than splitting it up into 4 individual squares like this, I just made one little slit here between the yellow and green squares and kind of folded it out. So you can imagine if you do that, you fold it out, you get this kind of figure here. Or if you folded this back, you'd recover the sides of your cube and you would just put the top and bottom on to finish the cube. Now, there's a couple of key ideas. The first thing, I'll just do this in black, I think, is that, well, we have a height of our object, in this case a cube here, and if you think about it, well, that's just that height there. So that's the same height. So we know one of the dimensions of this rectangle. But what about the other one? Well, maybe pause the video and see if you can think about what this length needs to be. And the hint is it does relate to the bases of your prism here. Okay, now that we're back, the important thing is, if you think about it, each of the sides of my bases here corresponds to one of these colors, like this front. So the front is yellow, so this here we can think of as a yellow line segment, if you will. So it's part of this yellow square. It's attached to it. And similarly, the right one is green, the back one is blue, and the left one is red. That's kind of looking at this cube. You can almost think of it looking at it top down. But if we think about it, they match up here, of course. Yellow, red, blue, and green. So what is this? Well, this length here is the same as the length of the outside of our shape here, which is, of course, the perimeter. So this dimension of the lateral faces of our prism is the perimeter of the base. So that's awesome. So the surface area, we'll use SA for surface area, is indeed, well, it's 2 times the area of the base. Since we have 2 bases, it's the area of this base, the top base, plus the area of the bottom base. Remember, in a prism, they are the same polygon, so they have the same area, plus the area of the outside, the lateral faces here. So what is that area? Well, we worked it out. It's just the perimeter of the base times the height. Now, we'll keep this here for a second. I want to talk about a few more prism and prism-like shapes. Here we have a hexagonal prism, and just because I don't have enough colors, I just labeled the sides 1 to 6. So the back is 1, and then going from to the left, we have 1, 2, side 3, side 4, side 5, and side 6. And again, we can take off the two bases, the top and bottom bases, and we can split our lateral faces just somewhere, say here between 1 and 6 is where I did it, but there's no particularly special place. So it looks like this. Now, what are the dimensions of our rectangle here? Well, the dimensions are, well, it has height h. This is our h. And just like before, we can look at this. This side belongs to kind of lateral face 1. This is 2, 3, 4, 5, and 6. So here we have a line segment of length 1 plus 2 plus 3 plus 4 plus 5 plus 6. That's the perimeter of our base. And hey, look, the same formula works. The surface area is 2 areas of the base plus the perimeter times the height. The last type of object I want to talk about just for now is this cylinder. Well, a cylinder, that's a prism-like object. We have 2 of the same, they're not polygons, but they are 2-dimensional objects, and we just kind of draw perpendicular lines down to them. You can think of this like a soup can. And again, we take off the top and the bottom, and we're left with the outside of our soup can. You can think of the label. What's the size of that label? Well, just like before, it has height h. And if you think about it, well, this length here, this needs to wrap all the way around the soup can. So it is indeed the perimeter of the base, or we call it the circumference, if you like, or perimeter of the base. So, the formula for the surface area of the cylinder is the same thing. 2 times the area of the base, 2 times the area of our circles, plus the perimeter of the base, or the circumference, times h. So, this formula holds for all prisms and prism-like objects. So, holds for all prisms and prism-like objects. So that's really nice. We have this nice simple formula just in terms of the area of the base and the perimeter of the base and the height. And it's one of these things you can kind of recreate if you forget it just by doing a little example here. That's the nice thing about some of these formulas, is they're quite easy to see if you're thinking mathematically. So there is the surface area of a prism. Now let's talk about pyramids. There's a little more to say about pyramids. Okay, there's a couple of concepts that are important with these pyramids to determine surface area. And the first one is this idea of a slant height. So the slant height, we usually call it L for whatever reason. That's not the height of the pyramid. Remember, the height is, well, if you just measure how far it is from the tip to the center of the base, then that's the height. The slant height, which is different, it's the length from the tip down the height of your pyramid to the midpoint of the other side. So here's an example of a square pyramid that I drew with a height and a slant height. And I tried to draw a regular pentagonal pyramid, and this one has a really short height. It's not particularly tall. But I did that for a reason, So you can see, especially when the height is small, the slant height can be quite a bit longer than the actual height. Think like a circus tent or something like that. Some tent that's really low to the ground. The height of it, the distance from the top to the center is going to be short, while the distance along the slant of one of the sides is going to be quite large. And the other thing I wanted to point out is, well, you can really figure out one from the other as long as you know the apothem. I'll use the letter A for apothem. The apothem of our regular polygon. Remember, the apothem is the distance from the center to the midpoint of any side. And the reason we can do that, hopefully you can visualize this, but if you join up the slant height with the actual height with the apothem, you get this right angle triangle kind of cutting through the middle of your pyramid. So that's really cool. And down here, same idea. We have the slant height, which is our hypotenuse, and then we have this apothem and the actual height of our pyramid meeting at a right angle, just like we did up here. And it's cutting through the middle of our pyramid there. So note, our first note is that the slant height L never equals the actual height H. That just doesn't happen for a pyramid. The slant height is always larger. So maybe I can even make this stronger by saying the height is always smaller than the slant height. That's something we always know. And the second note I want to make is that right angle triangle note. So the slant height is always the apothem squared plus the actual height squared. So we always know that. And that's going to help us out when it comes to the formulas for surface area of a pyramid. And the whole idea here for all of these, what we're going to do is we're going to do kind of the same thing that we did in the previous slide when we were talking about prisms. We're going to make this into a bunch of two-dimensional objects, and the way we're going to do it is we're just going to kind of nip out that center there and fold it down. So if we do that, I'll just draw this over this way. What we get, I'm going to draw it a little bit smaller just for room, but it's the same idea. If we fold down those sides, it's something that looks like this. So there are those four sides. They're all supposed to be the same. Those triangles are meant to be the same. And of course, well, they each have side length S because they're a square. They're a regular four-gon is our base. And each of the triangles has a height of L. And that's going to be really key for us. And before we start looking at the formula for surface area of a pyramid, let's just draw this guy folded down. It's called the net of your polyhedron, if you want to use a technical term, but it doesn't really matter. So again, this is supposed to be a regular five-gon, a regular pentagon, and there are the triangles coming off it. These ones look something like this. And again, they're all supposed to be even. They all have the same side length because it's a regular pentagon. And they all have the same slant height. So remember, even though these don't look even, they are. And as a reminder, maybe I'll write this as a reminder, the area of a regular polygon is half the perimeter times the apothem. So we're going to use that fact because we do have a bunch of regular polygons here. So let's see if we can figure out a formula for the surface area. Let's do the first one. Well, we have the area of our base. So it is a square, so we could write it as s squared and then plus these 4 areas of the triangles, which is of course base times height over 2, base of s, height of L. So s times L over 2, and we have of course 4 of them. So I can write it like that. The area of the base plus 4 areas of our triangle. Maybe I'll write that in a different color. So area of the base plus 4 areas of our triangles. But you can see here, well, the apothem is just s over 2. It's half the length of a side. And if we work, and the perimeter is, of course, 4 times s. So if we work out a half times 4s times s over 2, we get s squared. So, of course, that formula gives us s squared. So I can look at this as half the perimeter times the apothem, that's our area of the base. And the next thing I want to point out, well, look at this. We have 4 times s. We have s plus s plus s plus s. This here, 4 times s, this is the perimeter of our object, which is the regular polygon. So I'm going to write that as p times, I'll write it like this, L over 2. And let's make this formula a little bit nicer. I see a factor of 1/2 p in both terms. Here's a p, here's my 1/2, here's a p, here's a 1/2. So let me factor that out. And what do I get? I get 1/2 the perimeter times a plus L. And you can check that indeed if I multiply this back, I get exactly our expression. So I did this correctly. So we have exactly what we want here. If we calculate the surface area in the bottom pentagonal example, we're going to have the same thing. It's a half times p times a. That's the area of the base here. Remember, the area of a regular polygon is half times p times the apothem. Plus, now we have 5 of these triangles, and the triangles all have area base times height over 2. Oh, maybe I'll put the s first, because it is the base of our triangle. S times L over 2. And the same ideas hold. Here's 5 times s, s plus s plus s plus s plus s. That is indeed the perimeter of our regular polygon, in this case a pentagon. So, let's simplify this the same way. This is 1/2 PA plus P times L over 2, which is, of course, the exact same thing as above. 1/2 PA plus L. So let's write that in general on the next slide. So, in general, we have that formula for the surface area of a pyramid. Half the perimeter times the apothem plus the slant height, which is pretty cool. And note this does apply to cones as well. And the idea with cones is you can think of a circle almost as a polygon with infinitely many sides, which are really, really small. And in that case, the radius and the apothem are basically equal. That's a little bit of a fudge, but it's good enough for our purposes. So, we can use this formula to talk about the surface area of a cone. Same idea, half the perimeter times A plus L. Well, we know the perimeter of a circle is, of course, 2 pi r. So it's half times 2 pi r times this A plus L, but remember, A and R in a circle are basically the same thing. So R plus L, and that simplifies to pi r times R plus L. So for a cone, you're basically using the same formula, which is pretty cool, actually. And again, note, this only applies for right regular pyramids. Remember, we need that regular polygon to even talk about an apothem. Now, maybe it's a good idea to do a couple of problems just to see how our understanding is going. So that's what we'll do in the next few slides. Okay, so here are our two objects. One is a prism, and this is supposed to be a nice right prism, and one is, of course, a pyramid, and I want you to find the volume and surface area of both of these. Note that in the prism, the base isn't kind of a nice, neat shape, so you might have to do a little bit of work to calculate the area of this. We have that it's kind of like a rectangle here, and then it has a triangle on kind of the left side, and this length on both sides is 5, which tells you that this is indeed an isosceles triangle. So if you draw a line down the middle here, I'll do this in green, it meets the other side at the midpoint, so it breaks up that line here into 2 equal pieces. So, pause the video and give these a go. Calculate the volume and surface area of these shapes. Remember, you're definitely going to need the area of the base for each of these guys in order to calculate this. Okay, now that you're back, let's go ahead and do it. We know this is a prism, so we're going to calculate the volume as, of course, area of the base times the height. Height is easy. We have the height. It's given to us. It's 12. So that bit is easy. The area of the base, we're going to have to do a little bit of work here. So, let's just go ahead and do it. So the area of the base, well, I look at it this way. It's the area of this triangle here plus the area of this rectangle. So I'm going to call this the area of the triangle plus the area of that rectangle. The rectangle is easy. That's a 10 by 6 rectangle, so the area is 10 times 6. The area of the triangle, well, it's a little bit harder. It's a base times height divided by 2. We have the base is 6. But what is this height? Well, Hopefully you guys figured it out. If not, pause the video and see if you can figure it out. Well, this meets at the midpoint, and we're dropping a perpendicular line here. So that's a right angle. This splits my triangle into two right angle triangles, where this distance here, which I'll draw in blue, it was 6, and it got split into 3 and 3. So this right angle triangle here, this guy here, has a hypotenuse of 5. One of the legs is 3, and we have to solve for that green length there. So let's call that green length, I guess, B. So we know, of course, by the Pythagorean Theorem, that, I'll just do this over here, that 5 squared, the hypotenuse squared, equals a squared, which is 3, so 3 squared plus b squared, and I think it's pretty easy to see that b here has to be 4. And you can try solving that yourself just to check. So we know b is 4, and that's the height of our triangle there. So the area here is going to be the base, which is this length here, 6. So it's going to be base 6 times height 4 over 2. Remember, areas of triangles, base times height over 2. So we calculate this. So maybe I'll write this below just for room issues. 6 times 4 is 24. 24 over 2 is 12. 12 plus 60 is 72. So I know this is 72 units squared. We found the area of our base. So now, let's figure out the volume. So the volume is the area of the base, which is 72 units squared, times the height, which is 12 units. So our answer is 72 times 12, 864 units cubed. Okay, that's great. Now let's do the surface area. Remember, the surface area formula is 2 areas of the base, which we just figured out, plus the perimeter times the height. And I should say perimeter of the base, just to make it clear. Perimeter of the base times the height. So let's scroll up here. Just bear with me while I scroll. There we go. So the perimeter, well, there's no nice formula for this. Just add up the length of all the sides. So we'll start here. 5 plus 5 is 10. 10 plus 10 is 20. Plus 6 is 26. Plus 10 is 36. So the perimeter of the base is 36, just adding up all the sides around here. Be careful. I see a lot of students make a mistake. They'll add up this length here, but that's not really on the outside of our polygon. So just be careful about that. It's only a 5-sided figure, so we're going to add up 5 lengths. So we got 36, and the rest we have. Let me scroll back down. So we have 2 times the area of the base, which is 72, plus the perimeter, which you said is 36, times the height, which is 12. So this is 144 plus 36 times 12, so 360 plus 72 is 432. And if we add that, we get 576 units, and this is a 2-dimensional measurement. Area is 2-dimensional, so it's units squared. So hopefully that made sense to you guys. Let's do the pyramid now. Okay. So for the pyramid, remember, same idea. Maybe I'll do this in blue just to make sure it stands out against the writing in black to the left. Well, for B, the volume is, of course, area of the base times the height over 3. And we have all of those things, no problem. So the area of the base, well, we have a formula for that. Maybe we'll write it over here. The area of the base is half times the perimeter times the apothem. And we have all of that. So it's a half. Well, the perimeter is 6 times the side length. The side length is given as 2 times root 3, which is around 3.464. I'm going to leave it as 2 root 3 because it's a lot easier to deal with. So it's a half times, well, the perimeter is 6 times the side length, 2 root 3. That's our perimeter. Maybe I'll put that in square brackets just so you can see what it is. Times the apothem, and the apothem is indeed 3. So we calculate this. Let's just do a little bit of simplification here. So this half cancels with this 2 since everything's just multiplied. So I have 1 times 6, so 6 times root 3 times 3, so that is 18 times root 3. So this is 18 root 3 units squared since it's area, which is around 31.18 units squared. I'm going to leave it as 18 root 3 though. So this is 18 times root 3, that's the area of the base, times a height of 4 over 3. So we just need to calculate this. Again, I'm going to save myself a little bit of trouble by canceling off anything I can. I see a common factor of 3 in the numerator and denominator. 18 divided by 3 is 6. 3 divided by 3 is 1. So that simplifies things really nicely. So I get 6 times, or maybe I'll do it like this actually. I'm left with a 6 times 4, so that's 24 times root 3 over 1. So just 24 times root 3. And that is roughly, let me just tell you, that's roughly around 41.57. And it's units cubed since it is a volume that we solved for. Alright, that one wasn't too bad. Surface area, again, isn't too bad. We have that nice formula. So the surface area, remember, it's 1/2 times the perimeter times the apothem plus the slant height. We don't have the slant height, so we're going to have to solve for it. Remember, the slant height goes from the top of the pyramid down the side of it to the midpoint of one of the sides. And if you remember, I'll just do this up here in green. Remember that since L squared is the hypotenuse of this right angle triangle here, L squared equals A squared plus H squared. They're the legs of that right angle triangle. And solving for L, we get L is the square root of A squared plus H squared, which we know. So in this case, L is the square root of 3 squared plus the height squared, which is 4 squared. And you can calculate this to find that L is indeed 5. So that's great. We have our slant height. We can just plug everything in. Okay, so let's go ahead and do this. So this is 1/2 times the perimeter, which we calculated in the previous thing, is 6 times 2 root 3. Again, just remember, each of these sides I said was length 2 root 3. There's 6 of them in a regular hexagon, so the perimeter is 6 times that side length. And then times A plus L. And A plus L in this case, A is 3, the apothem is 3, and the slant height is 5. Again, we simplify this. I'll scroll to make a little bit of room. We have this 2 canceling out, say, with that 2, so we'll cancel that. And 3 plus 5 is 8. So we have 6 times root 3 times 8. So 6 times 8 is 48. So this is 48 times root 3 units squared. And if you're interested, 48 root 3 is around 83.14. But it's fine to leave it. In fact, more accurate, of course, to leave it with its square root in there if you like. All right, there are 2 examples for calculating volume and surface area of both prisms and pyramids. So hopefully this is helpful and you'll get some practice in further problems.